Hello everyone, and welcome to Prioritizing Pandemic Rates with Python. My name is Madelyn Kapfhammer, and I am a current fourth-year student at Allegheny College, a fairly small liberal arts school in northwestern Pennsylvania. There, I have had the opportunity to study both biology and computer science, fulfilling my interest and passion in both epidemiology and applying programming and data analytics to new and interesting problems. Now, let's take a few minutes to check out how I've been working with generalized disease models and optimization over the past year. A few of you may already be asking yourselves, what is an SIR model? Well, today is your lucky day because I am here to tell you. As a student studying biology, one of the first things that I learned about in disease ecology and epidemiology classes were SIR models, as they are a traditional backbone of disease modeling. SIR stands for Susceptible-Infected-Recovered modeling, as they track the number of susceptible, infected, and recovered individuals in a population for a given disease system. This disease system could be COVID-19, malaria, Lyme disease, you name it, there's a disease system for it. Susceptible individuals are those who are at risk for contracting a pathogen, possibly because of an autoimmune disorder, young age, or even old age. Infected individuals are just as they sound, those who have been infected with a pathogen, whether they are presenting symptoms or asymptomatic. And recovered individuals are those who were infected with a pathogen but have been able to eradicate it. SIR models are based in mathematics, focusing on differential equations to track the number of susceptible, infected, and recovered individuals in a disease system over time. While most people are under the impression that infection rate is the only thing that is accounted for in disease modeling, SIR models focus on all of the rates for a disease system, including host arrival rate, indicating how individuals interact with one another, recovery rate, indicating how quickly an infected individual recovers from pathogen infection, infection rate, indicating how quickly a pathogen itself infects a host and then begins to replicate, and death rate, how many individuals do not recover from a pathogen after infection. When I first learned about SIR models, one of the first things I did was ask myself how I could connect it to programming, specifically in my favorite language, Python, as I am sure many of you are doing right now. With a lot of curiosity and research, my interest in applying computer science to disease modeling led me to computational epidemiology, a field that combines computer science and public health to better understand issues central to epidemiology, including the spread of diseases or the effectiveness of public health interventions. While possibly digging myself into an even deeper hole, I discovered that you can investigate most disease-related topics through a lot of interesting Python programming. With my passion to start working in computational epidemiology, I built PandemicPriority, a tool for optimizing SIR models. Specifically, this tool uses the Python programming language, various Python libraries, and a random search algorithm to randomly generate a set of rates associated with a disease system, including host arrival rate, recovery rate, infection rate, and death rate. These random collections are then applied to the differential equations associated with SIR modeling to increase the number of recovered individuals over time and decrease the number of susceptible and infected individuals. This tool uses Pareto comparison to determine what set of disease rates generates the most optimal SIR model and disease system. When talking about pandemic priority in the past, a lot of people have asked me, how does optimization help in a real-life application of disease modeling? The answer is partially simple. Optimization helps us to understand what an ideal disease system looks like. This gets more complicated as public health workers must understand how disease rates, including host arrival rate, infection rate, recovery rate, and death rate, are connected, and what types of public health interventions affect these rates. Essentially, optimization helps us to understand what measures need to be put in place to increase the number of recovered and decrease the number of susceptible and infected individuals for a given disease system. These public health interventions can include specific treatment methods and preventative measures like social distancing and mask wearing, which we have been oh so familiar with throughout the COVID-19 pandemic. As I have worked further on pandemic priority, I have often caught myself asking, well, what's the point? Other than optimizing SIR models for my own fun and interest, how can others use this tool? Even in the pandemic world that we are currently living in, epidemiology is really difficult to understand, even for me as a current biology major. Specifically, disease modeling and public health interventions can be confusing. Many people have asked, why are we wearing masks, or why is socially distancing important? Pandemic priority provides an opportunity for individuals to understand what specifically goes into disease modeling and how public health interventions are developed. More than anything, this tool should be used to give individuals the opportunity to learn more about disease modeling and disease rates, a realm that is ever so important, and then, consequently, have the courage to be able to teach others about what they have learned. Now, I'd like to take some time to thank you all for coming to my talk, Prioritizing Pandemic Rates with Python. If there's one thing that I'd want you to take away, it's that you can combine biology and computer science fairly easily, especially in the realm of epidemiology. And if I can do it, you definitely can do it. If you're interested in learning more about SIR models, optimization techniques, or the personal projects that I've been working on, you can check me out on Twitter at @MaddieKapfhammer or my personal website, MadelynKapfhammer.com, where I document my progress on my personal projects as well as my experiences in computer science. Thank you all again, and I hope you have a wonderful rest of your day.